Welcome back. Today we're going to have a little whiteboard discussion. Obviously, the last couple of videos I've been calling things just straight up as it can be. No tactics to drive you towards a certain product. This channel is not monetized, so nothing that is shared on here is bringing money towards me whatsoever. I've retired from the performance industry, so any direction that might give you is not benefiting me in any direction or manner. But with the last video, we're talking about the cylinder head port in relation to the entire intake port design of multiple different engines. And within that discussion, somebody mentioned the 1980s variation of the smaller cubic inch engines in that 300 to 360 cubic inch range. So we're going to be doing a comparison today between the torque and horsepower of these combinations. Now, obviously throughout the muscle car era of engines, say the 1950s through the smog years of the 1970s, most of that technology has been perfected. Whether you're talking about the 302 cubic inch limits that were observed during the Trans Am series of the late 1960s, 1970s, and the cylinder heads and modifications that they had to those cars. Okay, even factory equipment was known to be well over 500 horsepower with a small block in that 300 to 360 cubic inch range. Now, this is going to be information that crosses over to all your different manufacturers. So it doesn't matter if you're a Ford, Chevy, or Chrysler fan. Each manufacturer has attempted to gain the most amount of performance and efficiency out of their engine combinations. Some of them were designed to fit in a certain package. So Chrysler, some of their smaller slant six engines were designed around a small package, mimicking some of the European models. But if we go back to the 1960s, especially when Pontiac in the early 1960s, when they introduced basically what was considered the first muscle car, this definition is going to be different between each individual. What do you consider to be a muscle car? Technically, a muscle car is something that is in a small package with a very large engine. So whether you're driving a Mustang with a V8, that could be considered a muscle car. I guess individuals from my generation, even some of the full-size cars, like the 64 Pontiac GTO, they were a full-size two-door car that normally tipped the scales at over 3,500 pounds. So that was the larger chassis. So in order for that vehicle to be a muscle car, it had to have an engine in the big block cubic inch range. Now, obviously, through technology, different crankshafts, cylinder bore designs, we can achieve big block cubic inch models out of a small package. So even the small block Ford can go up to 440 cubic inch. Same with the small block Chrysler. Chevys can go up to approximately 435 cubic inch. Some of the LS combinations can be well over 500 cubic inch. Some of the package engines that I've built in the past were 512 cubic inch LS1s. So it's not directly related to the cubic inch of the air pump that we're working with. And that's what's brought us to this discussion today, because during the 1980s, it was after the era of the 302 Trans Am or even 305 NASCAR engines from Chrysler. They already adapted the cast iron variations of cylinder heads intakes to that time frame. Now, you throw in the other manufacturers like Pontiac, AMC, even Buick, they took a different route. Even though there were departments, like Buick was the department of GM, their small blocks did not fall in the same category as the small block Chevy or small block Ford. They were not intended to be direct competition to them. So if you had a series with 305 cubic inch, you could attain 305 cubic inch out of obviously the Buicks and so on and so forth, but they weren't necessarily direct competition to the Chevys or even some of the Windsor tall deck blocks or even the Clevelands. Okay, so the direct connection to intake port velocities and flow and volume gave an advantage to some of those engines over the smaller companies like Oldsmobile or Buick. Not to say there were slouches, because again, they made up for it within other engine families like the Buick 455s, 421, so on and so forth. But if we're going to concentrate on the factory designs of 300 through 350 or 60 cubic inch, so that'd be Ford, Chevy, and Chrysler. And also I'll jump over to the 383 through the 500 cubic inch. That's going to cover most of your factory big blocks. So anything all the way up to the 500 Cadillac or 472, or the smaller 383. Obviously, I know that there was Chevys and Chryslers that were smaller in cubic inch than that, used in utility or heavy equipment. But for the average muscle car, they didn't come equipped with the 361. So normally the 383 was the entry level combination, that smaller cubic inch. So we're going to look at those two categories, and we're going to talk about the comparison between torque and horsepower. Now, again, in the 60s and 70s, they kind of had it figured out with the cast iron products. The early to mid 1980s was a very interesting era within performance. After the smog years and fuel consumption concerns, miles per gallon efficiency, the factories were restricted. At that time, they also had to add the catalytic converters, and they had to work with higher temperatures. So in the previous video, I mentioned with the motor oils, they weren't necessarily designed to work with the fuel, because even if you had blow-by with petroleum fuel that got into your oil, if you have these newer engines with all the additive packages into them, the fuel actually will cause the dilution of the oil and also the separation or breakdown of those additives. So yes, synthetic oils do provide a high temperature protection, and also allowing more of the heat to be shed off along with the thinner viscosity oils. It's not a direct comparison within the petroleum family. Even though synthetics are used as a base petroleum product, conventional oils are pure petroleum products. So with gasoline being invented to them, obviously it's going to break it down or thin it out, but it's not going to destroy the protective properties necessarily of the oil, unless it's an extravagant amount of gasoline that seeps by. Now, in the early to late 1980s, many of the manufacturers, having to deal with all the emissions controls and so on and so forth, is when they started introducing some of the fuel injection units out there. And many of the manufacturers were experimenting with multiple different engine packages, depending on what platform they're being used in. So I'm going to use two comparisons initially right here, and then we're going to add in the Ford, because Ford seemed fairly consistent with their 302 engines. You could obviously get them with different packages depending if it was going into a truck or the car within the intake systems, but they were fairly similar everywhere else within the engine. Obviously, they're all the same bore and stroke. Even the cylinder heads, even some of the later Ford Explorers came with the GT40 heads. So it wasn't something where you had to buy the Ford Mustang to get them. But most of your standard 5-liter Mustangs at the time, they had a certain package they stuck with. And it was very similar to the earlier editions of the 1960s and 70s. Chevrolet also continued on with the heritage of the small block Chevy. There's a reason why the small block Chevy became 50 years old, okay, where some of the other engine families were only around for a few years and kind of just disappeared. Will that be from the headquarter manufacturer to the economy, so on and so forth. Small block Chevy, small block Ford, and small block Chrysler, they held on for the years, okay? They are proven packages even within factory design. Now, when we're talking factory design, we're talking about anything from $120 to $340 horsepower. Okay, so not too many of the mid-1980s small block combinations came with 340 horsepower. There were some exceptions to the rule, so we're going to include them with this. The majority of your small blocks at the time, whether it be a 1985 Agarok Z28 to the 5-liter high output Mustang to some of the, I would say, argue with some of the performance models from Chrysler. As a Chrysler fan, the mid 80s was kind of a redheaded stepchild during the years of Chrysler small blocks. Most of their performance was actually dumped into the trucks. So there wasn't too many vehicle packages with performance. Obviously, there was the Velaris and Roadrunners and so on and so forth, but it wasn't as popular as, say, the Camaros or Mustangs. So we're going to use the Camaros and Mustangs and their 302 to 305 comparison to their bigger brothers within the small block families, the tall deck Ford 351 or the 350 Chevy. Now, specifically for the 305 cubic inch motor from Chevrolet, that made its way into the Monte Carlos, the Camaro, not necessarily the Z28 models, but some of the LT models. They're still considered a performance engine package, but they limited it to 305 cubic inch. Now, approximately in the 1980s, they also started introducing the Vortex cylinder head. For anybody that's a small block Chevy fan, realize that the Vortex cylinder heads, right from the get-go, they flowed additional air and were easily more performance-oriented than any other factory-installed cylinder head for the small block Chevy. So even you camel hump guys out there, the Vortex have an advantage over those, mostly because of the combustion chamber size. Now, even in the 305, the Vortex cylinder head was used. Also in the mid-80s, GM was throwing around the ideas with the fast burn design. So with the aluminum LT4 type engines using the Corvettes and some of the other models, they were a combination between the traditional small block Chevy cylinder head and the most modern technology. They didn't necessarily have the Vortex style combustion chamber, but they had a fast burn combustion chamber. So they were smaller in size, and it was directed to more performance orientation. The intake ports, believe it or not, are all very similar, anywhere from 165 to 185 cc's, even with the fast burns. Okay, so unless you turn to the aftermarket, that was the range of the intake port volume. Okay, now there was obviously different configurations that would flow more velocity, but that was the CC volume area of most of the cylinder heads, no matter if it was the Vortex or some of the higher end models. Now, when equipped on a 305, again, depending on the variant of the chassis or the option packages coming along, you could have anything from 120 to approximately 250 horsepower and still have a vehicle that met all of the emission standards and restrictions. Even after approximately 1985, the transition over to fuel injection. The previous video I mentioned that the cylinder heads can flow a lot compared to what the intakes were on most vehicles. It's the intake that is actually the restriction to the amount of flow that the engine can consume. You can have a cylinder head that flows 250 CFM, but if your intake system can only flow 225, that's a maximum you're ever going to get into the engine. The advantage, not only, but the advantage to having a large port cylinder head is to address the reversion and when the reversion occurs within the RPM range. So now going back to factory RPM, one of the questions that came up is, what do I consider to be a street RPM? Street RPM, for me anyway, would be 1,000 to 5,000 RPM. Most every engine in the 300 through 500 cubic inch range from the factory, that is where the engineers of all the manufacturers design their street engines to operate. Okay, the mass-produced engines, this was the RPM range that they were intending to match. In this RPM range, every single one of the manufacturers, every single one of them has a capable engine package. Now, once you start getting over 5,000 RPM is when you start seeing combinations like the Oldsmobiles or some of the, lower quality combinations when they start to fall apart or pull apart within connecting rods and so on and so forth. They're not designed from the manufacturers to be operated above 5,000 RPM. So now, going back to the 1980s when the 305 was transplanted into the Monte Carlos and Camaros, they were still using the same cylinder heads that were used on the 350 variations. So now any one of you can Google what the output was, difference between the 305 engine package to the 350. The 350 was worth approximately 15 foot-pounds of torque and approximately equal amount of horsepower. So if it was the 190 horsepower variation of the 305, the 350 with the exact same camshaft and exact same cylinder heads and intakes would come in anywhere from 210 to 225 horsepower. All right, depending on obviously other modifications that were equipped on them. The Mustangs in approximately 1985 to 87, they obviously also went to fuel injection. The GT40 type intakes and even the higher flowing exhaust allowed some of the Ford combinations to achieve more horsepower with the equal trade-off of torque. So the 302 Ford, not directly related to the cubic inch difference, did not create as much torque as the 305 or the 350, not just because of the cubic inch, but because of the cylinder heads. Now again, if you were to compare the factory cast iron cylinder heads of those days and compare them on a flow bench, your GT40s are not going to be as good as your Vortex. Your top of the line Ford factory casting is not going to match the flow of your performance fast burn or Vortex cylinder heads from Chevy. Now, for the 305 GM engine, they actually made a specific cylinder head for that engine combination because the bore or the stroke was the same, but the bore was quite a bit smaller. So the combustion chamber of the larger 76cc combustion chambers of the older 887 first generation Chevy cylinder heads, they would not match up very closely. So the Vortex style combustion chamber was equipped on the high output or the smaller combustion chamber, normally 58 cc's, was equipped on the 305. So the 305s in the high output variations, whether it be the Camaro or Monte Carlo, they did have a bump up in compression. They had it close to 10 to 1 or between 10 to 10.5 to 1 compression ratio. Exact same blocks as the 350. The 350 was the board variation of it. So where is the torque and horsepower advantage coming from? Is it coming directly from the cubic inch? That would make sense. More torque, more cubic inch, you're going to get more torque. But between the 305 and the 350, the intake ports flowed identical. So now in the aftermarket, what we have come to know today, when you get an engine and you're designing it for higher RPM ranges, above say 5,000 RPM, you want to increase the port volume size to be able to administer more air into the engine to create more power, more things that are online to the cubic inch. So if you're using a stroker 3D3 up to a 400 something cubic inch small block, you need larger ports to support the amount of airflow going into it, right? Easy enough. We all understand that. Now, you can achieve more airflow in the same manner without actually changing the port design. It's by creating a smaller engine. So now this is where I'm going to compare the small block Chrysler Obviously, the 350 and 305 are going to be in the same discussion here, and so are the 302 and 351s. They use the same cylinder heads on those two engine combinations. So whether it be the 50 or the 58, same cylinder heads. 305 to 350, same cylinder heads. Chrysler, exact same cylinder heads, whether it's the 5.2, 318, or 360. Now, remember that most of these cylinder heads were designed around a specific cubic inch, stemming back to the first generations of their kind. So going back to the 289, 302, the small block Chevy, again, the 273, 327, and later 350, and even 400. Chrysler, obviously, again, 260 cubic inch through 360. All right, easy enough. But they all used cylinder heads with the ports that flowed the exact same. So now what does that do within the RPM range of 1,000 to 5,000? That streetable standard operating range. In the mid-1980s, overdrive transmissions started making their way into the industry also. So instead of the engines being able to slip with torque converters at cruising speeds, once the transmissions were locked in, they created more load on the engine. So a lot more torque had to be addressed within that highway operating range. So anywhere from that 55 to 65 miles an hour. That's where most of the manufacturers concentrate on getting their most efficiency, and when their overdrive or lockup systems would engage within the transmissions. Rear axle ratios were also designed around that. So going back to previous videos when I've talked about that, the manufacturers designed V8 engines around the fuel source. Those engines are also designed around petroleum oils, conventional oils, not synthetics. And they're also designed to operate in that 1,000 to 5,000 RPM with the cruising speed of approximately 2,500 RPM, and depending on gear ratio or the type of highway you're driving around, it could be anywhere from a 308 gear ratio to 323. If it had something larger than that, say 355s, they normally used a taller tire to offset the gear ratio. That was the target point where most of these engines, no matter what manufacturer, were the most efficient for fuel economy and still had enough power to accelerate even with an incline, right? That was the original intent and design around from the factory. Now, between the 318 and 360, again, the only difference is cubic inch, but they use the exact same cylinder head. So out of the two combinations, are they going to make the same amount of power in exactly the same amount within the RPM range? Which head is going, or which engine combination between these two, while equipped with the exact same cylinder head, which one is going to run out of steam or air and fuel mixture to create more power? Which one is going to run out sooner? Obviously, the larger cubic inch, right? So the 360 with the additional cubic inch is more inherently going to be more torquey. And these cylinder heads are going to match the performance of that cubic inch at a lower RPM. So at 750 RPM at idle, a 360 is going to create more torque than a 318. But it's also going to fall off sooner to about 4,500 RPM. It's going to have a lower cruising efficiency rating, approximately 2,000 RPM. So the difference in power output between the 5.2 and 5.8 is literally 15 pounds, 15 horsepower. Okay, between 318 and 360 cubic inch. Bigger cubic inch separation and a very small performance differentiation, because the 5.2 has to work less in order to draw in the same amount of air as what the 5.8. It's going to be able to pull through 5,000 RPM, and it's going to be spinning faster when under load by approximately 250 RPM to 500 RPM. Okay? So going back to the previous video of finding the largest cylinder head flow as you possibly can, and then matching all the components to the RPM range. Again, the larger port of the cylinder head is more designed for the reversion. The Chrysler uses the same cylinder head. It's not going to change the reversion. It's going to change the reversion at the point in RPM that it does. Okay, so instead of getting maximum efficiency and torque by 4,000 RPM, the 360 is going to achieve it by approximately 3,750. But then after that, it's going to fall flat on its face within horsepower. The 305 to 350 Chevy comparisons, once again, the 305s normally came with a smaller combustion chamber and higher compression. But the ports flowed, or by volume, by cc's, they were exactly the same. And the 350s also used a larger valve. So a lot of times guys with the 350s would actually swap on a set of the 305 cylinder heads because of the smaller combustion chambers to give them more compression. Okay, with an additional compression, additional cubic inch, the high velocity port design that was designed for 1,000 to 5,000 RPM, the 350 with a head swap from a 305 was actually a killer engine. It would walk over the equivalent 302 from Ford. Okay, it would. You can go back to the magazine articles of the late 1980s and do comparisons of which one was faster. They were very, very close, depending on who was testing them and what option packages came onto them. Now realize the Camaro was heavier. So even though it had a 3 cubic inch advantage, it also had more than 300 pounds over the Mustang. So depending on what type of racing it was being done, normally the Camaro came out on top. Unless it was something that was very short spurts or had to slow down, then the Mustang had the advantage. But all the manufacturers are looking at their operating range somewhere in the 1,000 to 5,000 RPM. Now, equally, if we start talking about the big blocks of 383 through 500 cubic inch, those numbers are almost identical to the bottom. So the larger cubic inch small block was designed around 750 to 4,500 RPM. All of your 383s through 500s were designed in that same RPM range. Now, with all the different big block cylinder heads out there, some of them have a tremendous amount of volume within the cylinder head. Again, it's within the intakes that was the restriction to the total amount of flow. So depending on what engine combination you got, normally swapping the intake is where you've seen the greatest benefit. Comparing the 305 to 350, most of your TPI, two important injection systems, the cylinder heads flowed more than what the intakes did. So your Vortex cylinder heads or the fast burn designs of the 1980s, the cylinder heads could flow more than what the intake systems could. So by just swapping out the intakes, you would realize the actual power potential of the engines without swapping anything else other than the intakes. There was approximately, with the 305 high output to the standard like Z28 350, with an aftermarket intake change, there was approximately 35 horsepower difference, average, just from an intake swap. Is because you were allowing the cylinder heads to flow what they're capable of doing. Okay, so again, it was kind of neat during the 1980s, all the different variations of engine designs, especially with the introduction of fuel injection, what each manufacturer did to address the 750 to approximately 4,500 RPM range. It was all there about the efficiency. Now, approximately at the same time, the typical speed on our highways also changed. Up until the mid 1980s, most of the country, their highway speeds were 55 miles an hour max. Then they started bumping things up to 65 and even 70 miles an hour. That's the difference between 750 RPM to 1,000 RPM, or cruising speeds of 2,500 to 2,000 RPM. 55 to 65 miles an hour, 2,000 to 2,500 RPM. That's pretty much what it's all about, guys. So understanding what the manufacturers were intended on doing within the designs, stepping back all the way to the 1950s, adopting it to newer technology, they were not at the level of what the aftermarket was trying to achieve. Again, the aftermarket, they were trying to achieve a lot more than 120 to 300 horsepower. Okay, they were trying to achieve at least 1 horsepower per cubic inch. Obviously, that was achieved earlier in the 1960s, especially from Chevy with the 327s and the 350s. Again, with the camel hump heads in both of those circumstances. It wasn't until the late 80s and the use of aftermarket intakes that the 1980s models of the 305 or 350 cubic inch were able to match the 1 inch or 1 horsepower per cubic inch practice, still remaining in that 1,000 to 5,000 RPM range. Okay, the aftermarket was completely separate from the manufacturing engineers. They were designed and restricted within government regulations and the EPA. So hopefully that helps you all a bit. Very interesting time during the 1980s, and that transition didn't necessarily stop, because then in the mid 1990s, when Chevrolet came out with the LS and Chrysler started reintroducing the Hemi, it changed everything once again. And then Chevy with all the different variations of the LS1, LS2, LS3, LS6, LS7, they've gone through a continuous revolution. Again, it was all about manufacturing and tooling practices, adopting things that Chevy learned from Ford, believe it or not. The LS is actually an adaptation of the small block Chevy utilizing Ford technology. Okay, and Ford did the exact same thing. Ford learned with their small port first generation 302s how to achieve even more power by switching over to a higher flowing cylinder head, and obviously within the 4.6 or the mod motors. Okay, so each manufacturer bouncing ideas back and forth. Obviously Chrysler kind of stood alone and swapped from the Magnum engines directly into the Hemis. Here's one I forgot actually. With the 5.2 and 5.8 Chrysler engines, they used the exact same cylinder heads, and they also created an engine smaller, 4.7. Okay, so by the 4.7, the power range was actually shifted up. So it would be 1,500 to 5,500 RPM. Same cylinder head. Okay, so there was a marriage there from the intent of the original designers. Again, this is factory stuff, guys. Once we start getting into performance products that were sold over the counter or to race teams, everything changes. You know, that's when you start getting into the W2 heads from the small block Chryslers, or the Indy cylinder heads to Chevy, going to the 18 degree, 100 different options with cylinder heads that came out after that. And even the Ford come out with blue oval specials, or the aftermarket addressed it unanimously within stroker kits and so on and so forth. Your standard 351 became the 408, the Chrysler 408, the Chevy 406. That became a whole new genre of engine combinations, and they had to have the aftermarket support within cylinder heads to match it. So your 195cc engines, or excuse me, 195cc cylinder heads, all the way up to The standard pushrod location, 230 variations from Dart, Trick Flow, you name it. They're all over the place. Again, there was huge aftermarket support during the late 1980s through approximately 2010. At that point, some of the older variations and Chinese copies started taking over the world, and more individuals started transitioning over to the newer engine plants. So there wasn't as much attention given to the older 305s or 350s. There was a few bad apples in the 305s. Normally it was the head gasket issues. That's kind of what gave them a bad name. But the 305 Chevy engine was no slouch. The 302 has obviously been proven to be a good performer, especially up to that 550 horsepower mark. 350s, obviously there's a reason why they're one of the number one manufactured engine of all time. And same with Chrysler. You know, the LA engine, whether it be the Magnum configuration, it stuck along and it held out. It was always a good combination. Now, once you start getting into the Hemis, the LSs, the mod motors, and even the most newest generation of the EcoBoost and all that stuff, it's a totally different world. So as an old timer, we're kind of left out. But we have learned through all the different things, all the different engine combinations from the 1960s, 70s, 80s. It's a revolving technology that used to benefit us, and now it's pretty much being replaced with computer technology and no such thing as mechanics anymore. It's all technicians. Let's see here. What did I do with my tool? Now for you Chevy guys out there, I'm going to put one number here on the board, and without anything but the 3 digits of the number, tell me exactly what engine I'm talking about. Go ahead. In the previous video, somebody commented, and I left it up there, the LS6 and LS7. Okay. Now, anybody in modern day era that understands the LS engines of the modern day small block Chevy, when I had mentioned the big block cylinder head, they did make an LS7 in the big block Chevy. Now, some of you that are historians will recognize the snowflake mark. Now, again, going back to the conversation that these were factory engineered and high manufactured engines. The LS6 was the highest option offered by the manufacturers in a cast iron configuration in the big block Chevy. But a 427 was used by Chevrolet for the big block and also more modern day LS7s. The stroker combination of modern day LS engines also used the 427 cubic inch designation. The earlier big block also used the LS7 snowflake aluminum combination on their all aluminum big block Chevy. And it was something that was manufactured at minimal amount of numbers that could count for performance factory equipment. So while these Chevys, the Chevy Chevelles, the heavy Chevys, the 454 LS6, that was the cast iron variation. But the Camaros and some of the performance models that were bought over the counter were the same rectangular port, but it was the difference between the actual material of the cylinder head. The LS6 was cast iron, the LS7 was aluminum. That was it. So with that, hopefully it answers. Somebody tried to correct me, but that is exactly what occurred during the 1970-71 era of the big block 454, 427 Chevys. Okay, so with that, one last comparison before I let you go. What gets more torque, the 400 small block Chevy or the 396 big block Chevy? Cubic inch advantage goes to the small block, right? 400 cubic inches should create more torque than the big block 396. From a factory standpoint, the cast iron cylinder heads on a standard 400 small block Chevy flow at approximately 215 CFM in pure form. The 396, even the smallest variation in a performance model car, say Chevelle, Camaro, so on and so forth, use the oval port cylinder heads that would flow approximately 260 CFM. 215, 260. Cubic inch would say that the small block would create more torque, but the big block created more torque for two reasons. The additional airflow from these cylinder heads and also the weight of the rotating mass. The heavier the rotating mass, the more stored energy there is for torque production. Okay, so going back to the 305 to 350, exact same bore or exact same stroke connecting rods, but the smaller bore of the 305, it reduced the amount of power that could be exerted onto the crank. Same connecting rod angles, okay, rod ratios, so on and so forth. So the 305 had the torque advantage. But the higher airflow, as in the between the 400 and 396 comparison, the 305 actually had the advantage to the amount of airflow available through the factory cast iron heads. Hopefully that has answered some of the questions and comments that have come through. Again, this is completely different than the aftermarket. Okay, once you start talking about the aftermarket, more modern day LS or all aluminum combinations, mod motors, dual overhead cams, all of this information can basically be thrown out. Okay, because they have done other things to address torque, RPM ranges, so on and so forth, lightening up the rotating masses, different transmissions. Instead of a 3-speed with an overdrive, now you got up to 10-speed transmissions. So your cruising speeds and your efficiency levels are completely different. The advantages of different fuel injection, whether it be direct cylinder, has also changed the size requirement for intake ports. They're not carrying the fuel anymore. The fuel's meeting the air in the combustion chamber. So all this information is completely just for older muscle car engines, no matter what manufacturer it's from, to address the torque and horsepower in either the small block combinations or big blocks. It's the same technology. It's the same air pump. And how they works off the same ambient air pressure. That's it. Have a good one.